Okay, if we were to differentiate trig functions, right, you're going to need to remember this. If you've got y equals sine x, then dy dx just equals cos x. Okay, right, that's the result. And if you've got y equals cos x, dy dx will equal minus sine x. Okay, so you've got to remember that. They do kind of switch, don't they? But cos x becomes minus sine x, right, when you differentiate it. Tan x, right, now that result's given in the formula booklet, right, so if you look in the formula page on differentiation, it's that one there, right, so tan x is sec squared x, alright, so if we got y equals tan x, then dy dx will equal sec squared x, alright. Now, again, these are often questions given in terms of function of a function, so if I've got this here, suppose I've got y equals sine 2x, right, you need to think of this as sine of 2x, right? That's why this is a function of a function. Sometimes it's written in brackets, okay? So it's not sine times 2x, right? It's not sine times 2x. And we often say, don't we, sine 2x, we just say that, but it means sine of 2x. So the inside function is 2x, the outside function is sine, right? That's the key to that, right? Outside function is sine, the inside function is 2x. So sine of 2x. So what you do is, when you do dy dx, you differentiate the outside function. So sine becomes cos, doesn't it? Okay, of 2x, right? So you can put it in a bracket if you want. Okay, don't have to. So sine of 2x becomes cos of 2x. You have to put that there, right? You can't just write cos, okay? Because, you know, when you differentiate sine x here, it becomes cos x, doesn't it? The x must stay, right? You can't just write cos, because that doesn't make sense, right? The function is cos of x, sine of x. So sine of x becomes cos of x. And it's the same here. Sine of 2x differentiated, well, sine becomes cos, so cos of 2x. But then with the function of function rule, you differentiate the outside, don't you? Sine becomes cos, but then you times it by then the derivative in here. The derivative of the inside function is 2. So you get that. So you get 2 cos of 2x, right? Now similarly, if I had y equals, suppose for instance I have cos, and this time I have 2x minus 3, right? Something like that in there. Now that is cos of 2x minus 3, function of a function. So dy dx, right? Now cos becomes minus sine, alright? Because it's up there, isn't it? Cos becomes minus sine. But remember, you can't just write that down. You've got to have what it is, minus sine of 2x minus 3. That bit stays, right? And then you times it by the derivative of the inside function, which is just differentiate that. It's just 2, isn't it? So you get then this. Bring the 2 to the front. So you get minus 2 sine of 2x minus 3. All right? So we could go on and on like this. I mean, sometimes you get something like this. You'd have cos, say for instance, x squared plus 3x. Okay, you could have that, right? Well, differentiate it, dy dx. Differentiate the outside function. Well, that's cos, isn't it? The cos is the outside function. The cos becomes minus sine of this. And then you've got to times it then by the derivative of the inside function. The inside function is this. So that becomes, we differentiate that, you get 2x plus 3. And that kind of looks a bit confusing. So the 2x plus 3 would go at the front. So you get that then. Okay, to make sure you've got that sine of x squared plus 3x at the end. Alright, now tan x, okay, let's just do one on that. Suppose I got y equals tan 2x, okay, then dy dx. Now the result for tan x, remember we saw in the formula booklet, is sec squared x, so it becomes sec squared 2x, right? Okay, you said, you don't have to put a bracket around them, but the tan becomes sec squared, okay, so, and if it's tan x, it becomes sec squared x. Now, if it's tan 2x, it becomes sec squared 2x. But then you've got to times it by the derivative in here, which is 2, alright? So you get 2 sec squared times 2x, alright? So something to think about there.